All right, let's jump right in, shall we? Tonight, it's all about meteor showers.
The celestial events that have, well, they've kind of captivated humanity for centuries, haven't they?
Absolutely. You know, I always find it amazing that those streaks of light we see, those shooting stars, are actually, well, they're like remnants, kind of like leftovers from the very early solar system.
It really is incredible when you think about it like that.
That's like, I don't know, like having a front row seat
Yeah,
to a cosmic time capsule.
that's a great way to put it.
And to help us unpack, to kind of dig into all the science, the wonder of these events, I've got an expert with me.
Happy to be here.
Now, I mean, we all kind of know the basics, right? Like a meteor shower that happens when the Earth, well, when it passes through a trail of debris, like
Okay.
stuff left behind by a comet
Right.
or an asteroid.
Exactly.
But what I find really intriguing is that, well, by studying the composition, like what those tiny meteoroids are made of, scientists can actually piece together, like a puzzle, the history of our solar system.
Yeah, it really is like cosmic archaeology.
Like how it formed, what it was made of, even the conditions, the environment, I guess, that might have led to, well, the emergence of life on Earth.
Exactly. Those tiny particles, like most of them are no bigger than, just a grain of sand.
Hmm.
But they hold so much information about our origins. And it's fascinating because, well, we're constantly refining our understanding, For a long time, it was thought that comets, those are the primary source, like the main thing that was causing the meteor shower debris.
Oh, interesting.
But now we know that some showers, like the Geminids, for example,
The Geminids.
those were actually caused by asteroids.
Oh, wow. So not all meteor showers are created equal then.
Exactly. And the Geminids, well, they're a particularly interesting case because the parent body, the thing they come from, is asteroid 3200 Phaethon.
3,200 feet then. I'll have to remember that.
And it behaves, well, it kind of acts a bit like a comet, actually, in that it sheds material, it kind of leaves stuff behind as it orbits the sun. And this has sparked, well, a lot of debate, I guess, about where you draw the line,
Between an asteroid and a comet.
Yeah. Like what makes one an asteroid and one a comet? It's a hot topic in astronomy right now.
Huh. So the Geminids are kind of like the rebels of the meteor shower world.
I like that analogy.
Mm-hmm.
And it's amazing to think, well, that we can actually see this cosmic dance, just by stepping outside into our own backyards.
Yeah, it really is.
Yeah, and one of the most remarkable things about meteor showers, well, is that they're predictable.
Oh, that's handy.
Yeah, because Earth passes through, well, the same debris trails. You go through the same paths, basically, roughly around the same time each year.
So we know when to look up?
Right. We can anticipate these spectacular shows. Take the Perseids in August, for example. They're kind of a crowd favorite because they're reliably active.
They put on a good show.
They do. And they happen during the warm summer months, which, well, perfect for late night viewing, right?
Oh, yeah, for sure. The Perseids, I remember one summer I was out in the countryside, far from any city lights.
Right.
And the Perseids that year, they were just incredible. It was like every minute there was another streak of light just across the sky.
Wow.
Really makes you feel connected, I guess, to the vastness of space.
Absolutely. It's a powerful feeling.
Yeah.
And while, the Perseids, they are pretty well known. There's another shower, well, one that I find particularly captivating, the Leonids. Those peak in November.
November, okay.
Yeah. And what sets the Leonids apart, what makes them different, is their history. Like back in 1833, they produced, well, one of the most intense meteor storms ever recorded, like thousands of meteors per hour raining down from the sky. It sparked, well, widespread awe,
Yeah, I can imagine.
even fear, Imagine witnessing that.
Wow, thousands per hour. That must have been, well, an unforgettable sight. It's incredible how these events, how they've kind of been woven into, I guess, our history and our culture.
Exactly. Like the 1833 Leonids, they were a pivotal event, something that really ignited, that kind of set off public interest in astronomy. And, well, it led to some of the first, scientific investigations into what meteor showers actually were.
Mm-hmm.
A real turning point in our understanding of these phenomena.
It's fascinating, isn't it? How even seemingly, well, random events like meteor showers can have such a profound impact, I guess, on our collective knowledge.
It really is.
Speaking of knowledge, I know that predicting the intensity of a meteor shower, well, it's not an exact science, but scientists have gotten pretty good at it, right?
They have. It involves a lot of, well, A lot of complex calculations, taking into account, well, the density of the debris stream, the gravitational influences from planets like Jupiter, and even the angle at which Earth intersects the stream. Organizations like the International Meteor Organization, they collect data, they collect information from observers worldwide all over the planet and use sophisticated models. They've got these fancy programs basically to make forecasts to predict when and where they'll be.
So it's like a cosmic weather forecast. And while those forecasts, they can tell us, well, when and where to look, there's still an element of surprise, right? We never know for sure just how spectacular a shower will be.
You got it.
Yeah.
That's part of the allure, isn't it?
Yeah.
That element of unpredictability. Even with the best forecasts, nature always has a way of throwing us a curveball. Some years, a shower might exceed expectations and put on, a dazzling display. While other years, it might be a bit more subdued.
Yeah, it's like a cosmic lottery.
Yeah.
You never know when you'll hit the jackpot.
That's a good way to put it.
But even if it isn't a full-blown meteor storm, there's still something magical about seeing those streaks of light.
Oh, for sure.
Knowing that they've traveled vast distances, through space and time.
It really does put things in perspective, doesn't
Yeah.
it? Makes you realize just how small we are.
Yeah.
In the grand scheme of the cosmos.
For sure.
And speaking of those streaks of light, have you ever heard of fireballs?
Fireballs?
Or bolides?
I have. They're like the supersized meteors, right?
Yeah.
The ones that can light up like the entire sky just for a brief moment.
Yeah. They're caused by, larger meteoroids entering the atmosphere.
Okay.
And they can be incredibly impressive to witness. I mean, some fireballs are so bright
Yeah.
that they can even cast shadows, like shadows on the ground.
Wow.
And their trails, the trails they leave behind, can linger for seconds or even minutes.
Wow. I bet that's a sight to behold. Are there any particular showers? Are there any specific ones that are known for producing these fireballs?
The torrids.
The torrids. Okay.
Which occur in October and November. They're known for having a higher than average number of fireballs.
Mm-hmm.
They're often described as slow moving and colorful.
Oh, okay.
Which makes them even more captivating.
Slow moving and colorful. I can picture it now.
Yeah.
Sounds almost hypnotic.
It is.
But on a more serious note, I've heard that these larger meteoroids, the ones that cause these fireballs, they can pose a risk.
They can.
To satellites and spacecraft.
There's definitely a potential risk there.
Yeah.
Although, it is relatively low.
Right.
Even if these larger meteoroids burn up, like they burn up in the atmosphere, they can still create a trail of ionized particles.
Mm-hmm.
And those particles can interfere with radio communications.
Oh.
Or even damage like sensitive equipment on satellites.
So it's like a cosmic game of dodgeball.
Kind of.
Where we're trying to avoid those speeding spice rocks.
In a sense, yeah. And to mitigate those risks, space agencies like NASA, for example, they monitor meteoroid populations. They keep track of them, basically, very closely. They use a combination of, ground-based observations, radar tracking, and even space-based telescopes to keep tabs on these potential hazards.
It's incredible to think about the level of effort, the amount of work, I guess, that goes into protecting our technology from those tiny particles of space debris.
Well, they might be tiny, but they can cause some big problems.
Yeah, true. Sure.
It just goes to show how interconnected everything is. I mean, from those minuscule grains of dust to the satellites that orbit our planet.
Absolutely. It's a reminder that we're all part of this intricate cosmic web. And speaking of interconnectedness, I think it's important to mention the role that amateur astronomers play.
Oh, yeah.
In meteor shower research.
Huge role.
Oh, absolutely. Citizen scientists they're making valuable contributions.
All the time.
Yeah.
Organizations like the International Meteor Organization, they rely heavily on observations from amateur astronomers.
Really?
Of all over the world.
Wow.
These individuals, they dedicate, countless hours to observing meteor showers, meticulously recording their observations and submitting them to databases.
Wow.
This data it's invaluable for scientists studying meteor shower activity, and it helps them refine their forecasts and their models.
It's a great example of I guess, regardless of their background, can contribute to scientific advancement.
Absolutely.
I bet it's pretty rewarding. I bet it feels pretty good
Yeah.
to know that your observations, that the stuff you're seeing is, well, it's helping to shape our understanding of the universe.
Oh, it is. It really is. And it speaks to, well, it speaks to the power of collaboration, and the importance of engaging the public in scientific endeavors.
Yeah. Oh,
After all, the night sky, well, it's a shared resource, and everyone should have the opportunity to experience its wonders and contribute to our knowledge of the cosmos.
Well said. And on that note, are there any particular tools or techniques that amateur astronomers can use to enhance their meteor watching experience?
The most important thing is to find a dark location, a place that's away from city lights.
Okay.
Light pollution it's the enemy of stargazing. So the darker the sky, the more meteors you'll be able to see.
So escaping the city glow is key.
It is.
Sounds like the perfect excuse for a camping trip.
Exactly. And once you've found your spot, make sure to dress warmly, bring a comfortable chair or a blanket to lie on,
Okay.
and allow your eyes to adjust to the darkness. This might take, I don't know, maybe 20, 30 minutes.
Wow, that's a while.
It is, but it's crucial for seeing fainter meteors.
Patience and preparation are the keys to a successful meteor watching experience.
Yeah.
And I guess it helps to know when and where to look, which is where those meteor shower forecasts come in handy.
Right. Those forecasts, those can tell you the peak viewing times.
Okay.
And the location of the radiant, which is, it's the point in the sky from which the meteors appear to originate.
So a little planning can go a long way.
It can.
But even if you don't catch a glimpse of a meteor, there's still, I don't know, there's still something incredibly calming and awe-inspiring about just lying back under a dark sky, gazing up at the stars.
It's a humbling experience, isn't it? Makes you realize our place in the universe.
Yeah.
And appreciate the beauty and the vastness of the cosmos.
Yeah, for sure.
And, beyond the visual spectacle.
Right.
Meteor showers, they also offer us a unique opportunity to study the composition, like what these celestial objects are made of.
You mentioned earlier that studying meteoroids is like cosmic archaeology.
It is.
Uncovering clues about the early solar system.
It is.
How exactly do scientists go about doing that?
Well, it's not as simple as picking up a meteorite and analyzing it.
Right.
Most meteoroids they're completely vaporized when they enter the atmosphere. But scientists, they can still study their composition. They can still figure out what they're made of.
Okay.
Using a technique called spectroscopy.
Spectroscopy, that sounds pretty high tech. How does that work?
The spectroscopy basically involves analyzing the light emitted by a meteor.
Okay.
As it burns up. Each different element
okay.
emits light at specific wavelengths, and that creates, a unique fingerprint. It's kind of like a barcode.
Oh.
So by looking at the spectrum of light, the different colors of light, basically, from a meteor, scientists can determine what elements are present, what it's made of.
It's like reading the chemical barcode of a meteor.
Exactly.
That's incredible. What kind of information can scientists glean from that?
It tells us a lot about the conditions in the early solar system.
Oh.
For example, the abundance of certain elements, like how much of a particular element there is, can indicate the temperature and pressure at which the meteoroid formed. We can also learn about the processes that were happening, like back in the early solar system, things like the formation of planets and, the mixing of materials from different regions.
So each meteor is like a tiny time capsule.
Yeah.
Carrying a record of those ancient events.
Exactly.
It's amazing to think that we can access that information, we can learn all that just by analyzing the light they emit.
It is. It's a testament to the ingenuity of scientists and the power of observation.
And there have been some truly groundbreaking discoveries made.
Oh yeah.
Through the study of meteorites and meteor showers.
Yeah.
Like what any specific examples that come to mind?
Well, for one, the analysis of meteorites has provided evidence to support the theory that Earth's water may have come from comets or asteroids. Some meteorites they've got these tiny pockets of water that have that have a similar isotopic composition
Okay.
to Earth's oceans.
Wow. So our oceans might be filled with ancient comet water.
It's one of the leading
Oh,
theories.
that's
Yeah.
mind-blowing.
It really is, and it highlights the interconnectedness of our solar system.
Yeah.
We're constantly learning new things about our cosmic origins.
Mhm.
And meteor showers, well, they play a crucial role in that ongoing discovery.
It's fascinating how these seemingly fleeting events, these streaks of light across the sky can hold so much information about, well, about our past and potentially even our future.
And they really can.
Yeah, it really is mind-blowing to think that something as simple as a meteor shower
Right.
can unlock so many secrets
How many?
about our universe.
About our universe, it really is.
And for those of us who aren't scientists, who aren't, studying this stuff every day,
Right.
but are still captivated, who are still like, wow, look at that, by
Yeah.
these celestial events,
Mm-hmm.
I guess the best we can do, the best thing for us to do is get out there and experience them for ourselves, right?
Yeah. There's nothing quite like witnessing a meteor shower firsthand. It's a humbling and awe-inspiring experience.
Yeah, for sure.
That connects us to something much bigger than ourselves.
I know we touched on this earlier.
We did.
But any tips for those who are eager to catch the next celestial show?
Absolutely. The most important thing is to find a dark location, a place that's away from city lights,
Okay.
light pollution that washes out the fainter meteors. So the darker the sky, the more you'll see.
So it's all about escaping the city glow,
Yeah.
and embracing the darkness.
Exactly. Once you've found your spot, dress warmly.
Okay.
Bring a blanket or a comfortable chair.
Okay.
And let your eyes adjust to the darkness. This can take, I don't know, 20 to 30 minutes.
Yeah, wow.
But it makes a huge difference.
Comfort and patience.
Comfort and patience, that's the key.
You don't want a stiff neck or impatient mind,
Right.
to ruin the experience.
You got it. And remember, meteor showers they're natural events.
Right.
So there might be lulls in activity, like you might see several meteors, in quick succession, and then you might have to wait a while for the next one.
Right.
It's all part of the experience.
It's about enjoying the serenity
The serenity
of the night sky.
Yeah.
And savoring those moments.
Those moments.
When a meteor streaks across the darkness.
Precisely. And of course it helps to know when and where to look. Check online or use a stargazing app
Yeah, I love those apps.
to find out the peak viewing times for the shower you're interested in.
Oh, okay.
The app can also help you locate the radiant, which is, well, it's the point in the sky from which the meteors appear to originate.
Oh, right.
Yeah.
So a little preparation goes a long way in maximizing our meteor watching experience.
They dig.
But even with all the planning, I imagine there's still a sense of wonder
Oh yeah.
and surprise
For sure.
when you see that first meteor streak across the sky.
Absolutely. It's a moment of pure awe.
Yeah.
And for centuries, people have they've attached all sorts of myths and legends to meteor showers.
Oh, I'm all ears. Tell me more about these meteor myths.
Well, in some cultures, meteor showers they were seen as omens,
Oh,
either good or bad. Some believe they were signs from the gods,
right.
while others thought they were souls traveling to the afterlife.
It's fascinating how these celestial events, how they've sparked such diverse interpretations throughout history.
Yeah.
It speaks to our innate human desire, like our human need, I guess, to find meaning in the world around us.
Exactly. And even today, despite our scientific understanding of meteor show, there's still a sense of mystery and wonder.
Yeah, for sure.
Associated with them.
I think that's part of their allure.
I think so too.
They remind us that there's still so much out there that we don't know, so much to explore and discover.
Well said. And speaking of exploration, there have been some incredible space missions dedicated to studying comets and asteroids up close. Yeah. Missions like Stardust and Hayabusa, they've actually collected samples of cometary and asteroidal material, and brought them back to Earth for analysis.
Wow, actually bringing pieces of comets and asteroids back to Earth. That's That's mind-blowing. What have we learned from those missions?
We've learned a tremendous amount about the composition of these celestial bodies and the conditions in the early solar system.
Okay.
For example, the analysis of samples from the Stardust mission
Okay.
revealed the presence of organic molecules, like the building blocks of life in
Wow.
cometary dust.
So those tiny particles, those things that create those beautiful streaks of light in our sky, could potentially hold the key to understanding the origins of life itself.
It's a tantalizing possibility.
It is.
And it underscores the importance of continuing to explore our solar system and beyond.
It's incredible to think about all the secrets that are still out there,
I know, right?
waiting to be uncovered.
There it is.
And it all starts with those tiny particles of dust, those messengers from the cosmos.
It's a reminder that even the smallest things can have a profound impact on our understanding of the universe.
And on that note, I think we've reached the end of our deep dive into the world of meteor showers.
We have what a journey it's been.
It has been fascinating from the science to the history to the sheer wonder of it all. Meteor showers, they offer a glimpse into the vastness and the complexity of our universe.
And they remind us that we're part of something much bigger than ourselves.
Yeah.
Keep looking up.
Yeah.
The cosmos is full of wonders.
It is.
Waiting to be discovered.
Until next time, keep exploring, keep questioning, and keep diving deep.
Keep diving
into the mysteries that surround us.
Yeah.